guys. All right, hopefully our recording issues are over and we are good to go. So we're going to take a look at areas again today, but we're going to look for trapezoids, rhombuses, and kites. So we talked about a little bit of this in class and what these properties are and how it leads us to the formulas for specifically rhombus and kites we looked at. So what we look at is a trapezoid. If this is a trapezoid, and what they do is they say, hey, if I find the midpoint of this side and I find the midpoint of the other side, I can flip this top piece over here, rotate it around and lay it right next to this, and I end up with a really long, skinny parallelogram. And that's what helps us derive the formula for an area of a trapezoid. So the area of a trapezoid is equal to A equals 1/2, because we took 1/2 of these, of the height. We chopped the height in half. And then we, instead of just plain old base, we have base 1 plus base 2. So we had the base 1 plus base 2 along next side it, and that's where we get this formula from. So it does not matter which one you label base 1 and base 2. Those sub numbers just indicate, hey, you're dealing with two different bases. Similar to our parallelograms and our triangles, I can have an outside height, which is the altitude or the perpendicular height, or I could have an inside height, and it's also perpendicular to the opposite side. So it's going to be perpendicular to the bases. So the height of a trapezoid, so we'll call it a trap, is the perpendicular distance between the two bases. So instead of from a vertex, it's between the two bases. And then the bases themselves of a trapezoid are the parallel opposite sides. Okay, so what we need to do is get familiar with, comfortable with using this formula. 1/2 H, and then I add my bases together. So if we take a look at the state of Nevada, and we want to find the approximate area for Nevada. So when I use a formula, I should start by writing down the formula. And then substitute in the pieces I know. I know I have 1/2, and the height, remember the height is the perpendicular distance between the parallel lines. So if those sides are parallel, this is going to be my height, and that says 309. So 309 goes in for my height, and then my bases are the parallel sides themselves, the lengths of those parallel sides. So I have 205 plus my other base, 511. So at that point, I can put that exactly like I see it into my calculator, and out spits an approximate area of 110,622 miles squared, because it's miles times miles, which is miles squared. So these aren't too bad. It's just a matter of making sure you remember your bases are your parallel sides, and your height is the perpendicular piece between those two sides. So if I am looking at this trapezoid down here, we need to find the area. So the area is 1/2 height times base 1 plus base 2. So knowing what I have, I can do 1/2. I know one of the bases is 5, doesn't matter which order, and the other one is 7, because they are the parallel sides. But my height is the height here. It's the perpendicular segment between the two. I've got to figure out what that height is. So I can drop in an altitude to create a special right triangle. And if you see right here, it's a 60-degree angle. So I'm going to end up with a 30, 60, 90 right triangle. And if we recall our Ames reference sheets, we know that the long leg is equal to the short leg rad 3. Well, what's the short leg? From here to here is 5. So from here to that same spot must be 5. If the whole thing is 7, then this small piece right here must be 2. So my short leg is 2. I'm trying to find the long leg to find my height, because the long leg is across from the bigger angle, which is 60. So substituting the stuff I know my long leg is the height I'm looking for. The short leg is 2 times rad 3. So I can come over here and substitute in 2 rad 3 for my height. When I multiply in any order. So I can easily go 5 plus 7, that's 12, half of which is 6 times 2 rad 3, which gives me 6 times 2 is 12 rad 3. Go find your units, meters squared. All right, let's try this one. You can also use Pythagorean theorem. So this is just overlapping or non-overlapping figures. So I know I have right angle, so this must be a rectangle. So I know I have a base in this whole trapezoid of 14. So I'm going to call base 1 equals 14. And I got to figure out what this whole base is here. This is 14. And this is a piece I need to figure out. Oh wait, they gave it to me. It's just hiding inside. So that's 16. So my other base, the whole thing is 14 plus 16, which is 30. So area equals 1/2 height times base 1 plus base 2. So I'm going to substitute in the pieces I know right now. I know 14 plus 30. Again, we got to go back and figure out the height. The height here is this piece, the perpendicular piece between the parallel lines. Well, if I'm looking over, if this is a right angle, this must be a right angle. So this triangle must be a right triangle. I have two sides of a right triangle, so I can find the third one using the Pythagorean theorem. So I'm going to use the hypotenuse is 20. So 20 squared is equal to h squared plus 16 squared. So h must be equal to the square root of 20 squared minus 16 squared. And I find in my calculator that h is equal to 12. Once I know h, I can substitute the rest of what I was looking for into the formula. Half of 12 is 6. 6 times, what is that, 44? Is 6 times 44. Where's my calculator? 6 times 44. 264. And millimeters squared. Okay. So let's try. Okay, you guys pause and try the next three and come back and check your answers. Okay, there are your answers. If you did not get them right, make sure you pause, work through the numbers, check and see, double check my works, make sure I get those correct. I also use some rounding because sometimes in area instead of using exact, so depending on what they're asking for, we're playing around with both radicals and with approximating your radicals. Okay, so let's take a look. So that is trapezoids. Let's take a look at areas of rhombuses and kites. So we know from our Ames reference sheet that the area of a rhombus or a kite is 1/2 d sub 1 times d sub 2. That just means diagonal times diagonal and take half of it. So if I'm looking at this figure here, I got to figure out what's going on. So these are both rhombuses and these are both kites. They use the same area formula. So I know that the diagonals of a rhombus bisect each other. So I know that's also 4. And I know that they intersect at a right angle. So I know I have one diagonal. So D1 I'll call 4 plus 4, which is 8. And I've got to go figure out what this one is. So I need to figure out what this height is and double it so that I can get the whole diagonal. Well, it's a right triangle, so I should use the Pythagorean theorem. I know 6 squared is a hypotenuse equals, we'll call it h for now, h squared plus 4 squared. So I know h is equal to the square root of 6 squared minus 4 squared. So I'm going to solve h is equal to 2 rad 5. Now that I know what h is, that's this piece here, there's 2 of them to get the other diagonal. So my other diagonal, there's one of them. The other one, d2, is equal to 2 times 2 rad 5, which is equal to 4 rad 5. Now I have all the pieces, I just substituted into my formula. Area equals 1/2 d1 d2, 1/2 of 8 times 4 rad 5. Half of 8 is 4. 4 times 4 is 16, so the area is equal to 16 rad 5. And my units are m squared. So depending if they ask you to approximate it or to round it, 16 rad 5 is an exact answer. Calculator would give you somewhere around 35, 36 meters squared for an approximate. Okay, so the process is exactly the same. You just got to go find your pieces. I've got one diagonal. That's good. So I know that diagonal 1 is equal to 12. And I need to go find this other diagonal. So I'm going to drop in my diagonal. We know the diagonals of a rhombus create a right angle. So I've got 4 right triangles. So that means I can find the pieces that I need. This whole thing is 12, so this piece must be 6, and this piece must be 6. So now in this triangle, I have 6, and the hypotenuse is 10. So 10 squared is equal to, whatever you're calling it, x. X squared plus 6 squared. So that means x is equal to the square root of 10 squared minus 6 squared. So x is equal to 8. That's just this piece here. So if I have this piece is 8, then this piece is 8. So that means my diagonal is 8 plus 8, which is 16. Now that I have both diagonals, a is equal to 1/2 d1 times d2, which is equal to 1/2 12 times 16. That's 6 times 16. That is equal to 96. My units are yards squared. Okay, not so bad. Kites are even easier because they have to give you lots of information. We know the diagonals don't bisect each other, but we do know that the short diagonal is bisected by the other diagonal. We also know that kites come at a right angle as well. So if this piece is 8, then I know this piece is 8. So one of my diagonals is 8 plus 8, which is 16. This is my other diagonal. They gave me this is 8 and this is 14. So I know my other diagonal is equal to 8 plus 14, which is 22. I have the two diagonals. That's all I need for a kite. A equals 1/2 d1 times d2. 1/2 of 16 times 22. 8 times 22, what is that? 176. Units are inches squared. Okay, same thing here. I know I have 4 feet here and another 4 feet here, so one of my diagonals is equal to 8. And I got to figure out what my other diagonal is equal to. So let's take a look. We have 6.5 feet and another 2 feet. So my other diagonal is 8.5 feet. And I substituted it. 1/2 d1 d2 equals 1/2 of 8 times 8.5. And that's 4 times 8.5. That is 34. 34 feet squared. Okay, so pause the video. You try the next few and then come check your answers. Okay, there are your answers for these. This second one kind of got away from me, and it's over here. So I gave you the exact answer, and I gave you an approximate as well. So you need to be able to do both. So get in the habit of finding the exact, and then if it asks you for the approximate, you can put it into an approximate answer. Pause the video, rework those. Let me know if I got any of those wrong or what questions you have. Okay, the last couple I want to take a look at, and then we will be done for today. Is one here's in context. The high occupancy vehicle lane. So lane, that says lane. HOV lane, we're all familiar with that down in Phoenix, is marked by a bunch of diamonds. And these diamonds are technically rhombuses. And they're painted in that HOV lane. What is the area of the HOV lane marking? So we want to find the area inside this marking thing here. And so we know we have a rhombus. So we know we have area equals 1/2 d1 times d2. And we just have to figure out the pieces. So I need to find some diagonal lengths. They gave me this half of this is 2.5. So if this is 2.5 and this is 2.5, then I know one of my diagonals is 2.5 times 2, which is 5. So far so good? So then we have to go find the other diagonal. which means I need to find this piece right here. Again, the diagonals of a rhombus create a right angle. So I have a Pythagorean theorem that I can use to find the other missing piece. So I know 6.5 squared is equal to, we'll call that x, x squared plus 2.5 squared. X is equal to the square root of 6.5 squared minus 2.5 squared. I put that exactly like I see it into my calculator and get an awesome whole number of 6. If I hadn't gotten a 6, then I would need to leave it as a radical, simplify the step inside, and then simplify the radical. So now I know that x is 6. So my second diagonal is 6 times 2, because there's 6 up here, there's going to be 6 down here, equals 12. And I can substitute in the pieces. 1/2, my diagonal 1 was 5, times my diagonal 12. Remember, you can multiply in any order. So I can take half of 12, which is 6, then times 5. And that makes my math a little bit easier. Half of 12, where did I get 5 from? 2.5, 5? That makes sense. So 6 times 5, which is 30. And we're done with feet squared. Okay, again, some of our special right triangles will kick in. So we need to know those rules. If we don't, we can pull out our Ames reference sheet. So we have a rhombus, and I know this is 12, so I know this is going to be 12. So I know one of my diagonals is equal to 24. And I gotta go figure out what my other one is. I know it's a right angle. And this is the 30 degrees, so this must be my short leg. So in a 30, 60, 90 triangle, I know that the long leg, which is what I'm looking for, is equal to the short leg rad 3. So we know that this long leg here is equal to 12 rad 3. The diagonal is 2 of those, so 2 times 12 rad 3 is equal to 24 rad 3. I have both my diagonals, so I'm good to go. So area is equal to 1/2 diagonal 1 times diagonal 2. 1/2 of 24 times 24 rad 3. Half of 24 is 12. 12 times 24 is 288. 288 feet squared. Yep, same process. This time the second one though is instead of a 30 degree, I have a 60 degree. So we know this is the long leg here. I need to find the short leg and the long leg this time. But I know I have a hypotenuse. So I know that this is also 9 feet. And so I can use that piece of the 30, 60, 90 that talks about hypotenuse. So the hypotenuse is equal to 2 times the short leg. So this is 60, so this would be 90, so this would be this piece right here. So the hypotenuse is 9 is equal to 2 short leg. So if I want to solve for short leg, I divide both sides by 2, so I know my short leg is equal to 4.5. If this is 4.5, there's 2 of those that make up the diagonal. So I know one of my diagonals is 2 times 4.5, which is equal to 9. So this one is 9. And now I got to go figure out what this piece is. So 2 ways. Now I have 2 sides and I can use the Pythagorean theorem to find the third. Or I can still use my 30, 60, 90. This time I'm looking for the long leg is equal to the short leg rad 3. I'm looking for the long leg, this piece here. So it's equal to the short leg. My short leg is 9 rad 3. So there are in D2 2 of those 9 rad 3s. Short leg, short leg. Where's my short leg? Okay, sorry guys. Short leg is 4.5, not 9. That's the whole diagonal side. So this is 4.5 rad 3. That makes more sense. So now I have 4.5 rad 3 times 2. 2 times 4.5 is equal to 9 rad 3. If we take a look, we're going to start seeing a pattern. I have 24 for the length here, and I have the other diagonal 24 rad 3. Here I have one of the diagonals is 9, the other one is 9 rad 3. If I'm in a 30, 60, 90 triangle, that's what's going to happen. So once you find the one diagonal, you know the other one is just going to be the diagonal's length, rad 3. I have 2 diagonals now, so we can go find the area. Times 9 rad 3. 1/2 times 9, or 9 times 9 is 81, divided by 2. So we get half of 81, which is 40.5, rad 3. Feet squared. That's an exact answer. So when it says to leave it in radical form, then you should leave it in radical form. All right, one more, and then you're going to finish the rest for practice. We're looking at a 45-degree angle. The last thing we need to remember in a rhombus, hey, the opposite angles are bisected by the diagonal. So if this is 45, then this is 45. So this is a 90-degree corner. But if this is 90, then this one's 90. And if these two are 90, then this whole thing. So I end up getting a square. So even if I don't remember that, I still know I have the 45, 45, 90. And I know since I have a square, this is going to be 3, this is going to be 3, because the diagonals bisect each other in a square. This is going to be 3, and this is going to be 3. So I know my diagonal 1 is equal to 6, and my diagonal 2 is equal to 6. A is equal to 1/2 D1 times D2, which is equal to 1/2 6 times 6, which is equal to 18 meters squared. Okay, you try the next 3, and we'll see where you get. All right, there are your answers for your practice problems. Work your way through them. Let me know if I have any mistakes, because it's been known to happen. And I will see you in class on Monday. Thank you.